All right, so we're going to talk about types of error for hypothesis testing, and then we're going to go through a bunch of scenarios of, kind of like we did yesterday, write our hypotheses and identify which one's the claim. The reason we have to identify what the claim is because when we could do all the work that we're going to do without knowing which statement is the claim, but then when we summarize our results, there's 5 steps to a hypothesis test. First, you identify the hypotheses and identify the claim. Then you are going to find the data, the statistic from the sample. You're going to conduct the hypothesis test. You will then make a decision whether you're going to reject or not reject the null hypothesis. And then the last step is that once you say reject null hypothesis, you actually write a summary. It's a one sentence like blurb about what that rejection actually means for us. Okay, so in order to do that last summary, we need to know what the claim is because that is wrapped up in that last step, okay, in the summary. So we'll spend quite a bit of time doing that. Couple things that we need to understand. We reiterate this. We talked about it yesterday. It says no matter what hypothesis represents the claim, whether it's the null hypothesis or the alternative hypothesis, we will always make the assumption that the null hypothesis is true, okay? And then that null hypothesis is always going to be the one that involves equality, okay? We always assume it's true until we are able to identify through the use of data that we have sufficient evidence to say to the contrary, okay, to say that it is not true. Does that make sense? So you say it's true, we're in agreement that it's true until the data tells a different story, okay? Says we're going to have 2 decisions. These are only 2 decisions we're allowed to have. We either reject the null hypothesis or we fail to reject the null hypothesis, okay? When we fail to reject the null hypothesis, what that does is it produces the idea that we have evidence to support the alternative hypothesis, okay? The one thing I want to make sure we understand, though, is that when we reject or fail to reject, whatever decision we make, we could still be wrong. Does that make sense? Okay. And when we're wrong, but the data led us that way, we have what we call type 1 error or type 2 error. Okay. Type 1 error is referred to as alpha, which we've talked about. Okay. It's the same alpha that we've been talking about in our level of significance with confidence intervals. Okay. If I'm 95% confident, that means that I am allowing a 5% for type 1 error. Okay. And we'll talk about what type 2 error is as well. Usually type 2 error is identified by using the Greek letter beta. But I want to talk, I'm not so worried right now about us understanding the values attached to type 1 error and type 2 error, or even being able to recognize through a scenario, this is type 1 error, this is type 2 error. I want us to understand the concept of being able to run through a statistical test, make a decision, and that decision could still possibly be wrong, even in actuality, even though the data leads us to a certain decision. Does that make sense? That decision can be wrong, even if the data leads us that way. Is everyone on the same page with that? Okay. Same idea. It happens in a courtroom. We could convict somebody of a crime, and the data, all the evidence in that crime could lead us to a conviction, but that person, in actuality, now this person would be the only one that would know this, that person is truly innocent, but we convicted them based on the evidence, right? Okay. Or that person would be the only one that knows this, actually did commit the crime, okay, maybe stealing jewels from Hobby Lobby, okay, and they did commit the crime, but we do not convict them, okay? That's an error as well, all right? The seriousness of those 2 errors might be different, though, and that's something we're going to get into here in a little bit. So it said because the decision is based on a sample rather than the entire population, there's always a possibility you will make the wrong decision. Okay? Says, suppose you claim that a coin is not fair. You flip it 100 times to get 49 tails and 51 heads. So you say the coin's not fair, but you do a sample and you see that the coin probably, from that sample data, is fair, right? Okay. It says you would probably agree that you do not have a large enough sample size to support your claim. Okay, so 49 compared to 51 does not support my claim that the coin is unfair. Okay, it says even so, it is possible the coin is actually not fair. Okay, so I can't support the claim, but the data says that it's not fair. Does that make sense? I thought it was not fair. I go through a sample. The sample shows it's fair, but in all actuality, I have a coin that is ultimately not fair, that aligns with what my initial premise was, right? Okay? That would be what we call a type 1 error. Okay? We make an assumption, okay, or make a claim, and then the data leads us astray. Does that make sense? Okay? We want to minimize that. Okay? Same thing happens in this situation. It says, what if you flip a coin 100 times and 21 heads and 79 tails? Okay? 21 heads, 79 tails. Okay? With that data, you would agree that that's probably an unfair coin, right? Okay? But we could just have a poor sample here. Does that make sense? By chance, you can get poor samples. This sample shows me that this is unfair, but if I had the entire population, maybe the entire population tells me that that coin is 100% fair. Does that make sense? Okay? So there's always a little bit of error that can happen when we do sampling, and that sample then being used to do hypothesis testing. Okay? So we get two situations. Okay? You might reject a null hypothesis, okay, when it's actually true, or you might fail to reject a null hypothesis when it's actually false. I struggle with this. I struggle mightily with trying to remember this chart, okay? So this is what I do. I write this phrase here, R-A-A-R, okay? What was that? Say again, Lucas. I didn't say anything, you said it. Oh, you said it? What'd you say? Yeah, I knew you would. So I do it that, and this is, but it's forwards and backwards, right? And it's separated half. It's what are those words like mom and dad that you can read forwards and backwards? Like race cars one. Palindrome. Okay. So we got palindrome, and it's broken up. Once you find the middle of it, the left-hand side is the first part of it. The second, or the right-hand side is the second part of it, right? So the first part represents type 1 error. The second part represents type 2 error. Okay? So this is reject a null. This is all about rejecting or accepting a null hypothesis. So we reject when we should have accepted. Does that make sense? Reject. So here's the decision. Reject when you should have accepted. The intersection is type 1 error. So at the beginning, this is the left-hand side. I said that's type 1, right? Okay, it's the first thing. So reject when we should accept. Type 2 error is that you accept a null hypothesis, okay, when you should have rejected it. Okay? Does that make sense? All right. Now, the terminology, we don't ever use the terminology that we accept a null hypothesis. We use the phrasing do not reject. Okay? And basically, it's because we can't be 100% confident that we're going to accept it. So we just say we're not going to reject it. It doesn't necessarily say because we're not rejecting it that we're accepting. Does that make sense? When I tell you that I've got two triangles on the board and I don't put enough information on them to show that they're congruent, that doesn't mean they're not congruent, right? Doesn't mean the opposite, okay? It just means we don't have enough information. To make better decisions, okay, and to eliminate possibilities of error, we get bigger samples. The more samples we get, the bigger our sample size is, we can start to dwindle that error a little bit more. Does that make sense? Okay. Another way of thinking about it, if that doesn't make sense, you go down to, it's all about the court system, our justice system analogy that we talked about the other day. Okay. This is talking about how important, or the seriousness, I guess, of type 1 and type 2 error. So here is So these here align with, so H sub 0 is true, so null hypothesis is true. So that's being innocent, okay? If found not guilty, and I was truly innocent, right? In our legal system, you are innocent until proven guilty, correct? So innocence is the null hypothesis. That's the accepted truth until evidence shows otherwise, right? And that's what we're going to go through with hypothesis testing. We have an accepted truth until the data leads us astray, okay? Or leads us down a different path. So if somebody is innocent and then the verdict is that they're not guilty, that's justice. That's what we want, okay? And that's what we're hoping that our statistics produce, okay? It's basically saying that you made the right decision. If they're guilty and then we have a verdict that they're guilty, so they actually stole stuff from Hobby Lobby, and it's all right, you're 8, it's okay. So if you're guilty and then the verdict was guilty, that's justice as well. But if you're an innocent person, okay, and we find you guilty, okay, so you should have rejected, okay, a null hypothesis, right? Okay, rejected rejected something you should have accepted, okay? If we do that, then that's type 1 error. So you're innocent, but we called you guilty. You're now going to jail. You're an innocent person in jail, right? Now, for you, that's a bad thing, right? All right? So think about like level, and I don't know how you would argue this, but level of seriousness, maybe that only impacts a small group of people, you and maybe your immediate family, right? Okay? Let's say that you were guilty, but we let you go. Okay, so the verdict was not to reject the null hypothesis. Okay, so you actually committed a crime. Maybe you murdered somebody. We let you go. Now you are in the normal population as a murderer, right? Is that a level of seriousness that's pretty high now for the entire population? Okay, so level of seriousness on type 1 and type 2 error it differs, and it differs from situation to situation. All right, so we come down here to some scenarios here. Let's look at, I just got them written out here real quick to show. Maybe certain scenarios that, now they're not mathematical, but it's the idea of making the wrong decision, okay, and what kind of error could happen. So suppose the null hypothesis, H sub 0, is that Frank's rock climbing equipment is safe. Okay, so he's going to make the assumption that his gear is safe, right? Okay, that's null hypothesis. Type 1 error would be the idea that Frank thinks that his rock climbing equipment may not be safe, when in fact it really is safe. Okay, so type 1 error, if that were to happen, if Frank thinks his rock climbing equipment may not be safe, what's he probably going to do? If he thinks his equipment's not safe, what's he going to do? He's going to throw it away. He's not going to use it. He can go buy new, right? Okay. But it was safe in actuality. Is anybody impacted negatively there? No. Maybe Frank loses some money or whatever, right? But look at this one, type 2 error. Frank thinks that his rock climbing equipment may be safe, but in actuality, it's not. So he thinks it's safe, so what's he going to do? He's going to use it, and he's going to get stuck on a rock, and it's going to break, right? So now that's that level of seriousness, type 2 error in this situation, greater degree of seriousness than type 1 error, correct? Okay. Another one down here, say we got a victim of an automobile accident. Okay. So null hypothesis, victim of an automobile accident is alive when he arrives at the ER at the hospital. Okay. So that's the assumption. He's alive when he gets there. Type 1 error, crew thinks he's dead. Okay. Type 1 error, crew thinks he's dead. So what's the crew going to do if they think he's dead? Nothing. They're going to stop treatment, right? And then what's going to happen to that guy? He's going to die, right? So that's pretty high level of seriousness, right? Type 2 error, crew does not know whether he's alive. So if they don't know whether he's alive or dead, what are they going to do? They're going to treat him, right? And if he is in fact dead, in actuality was dead, and they're treating him, is anybody hurt there? No. Okay? Maybe waste some supplies, maybe some time, whatever. But the seriousness of type 1 and type 2 error, my hope is that we see that there is a difference in them, and from situation to situation, that seriousness might be more dramatic than others. Does that kind of make sense? Okay. Let's do this one here. Same idea, talk about the type of error, but we're also going to talk about the claim idea. I think one of the things that happens in reading these types of questions, doing hypothesis testing, is that a byproduct is like reading comprehension skills, okay? Because we have to really think about what's going on, what is being asked, what obviously is the claim, and then obviously when we go through the math and all that kind of stuff. But when we're done, then we have to justify, okay, this was the claim, the data led me to this decision, now summarize what that means to us in regards to what the claim was, okay? So it says the USDA limit for salmonella contamination for chicken is 20%. Inspector reports that chicken processed or produced by a company exceeds the USDA limit. So you perform a hypothesis test to determine whether the inspector's claim is true. It says when will type 1 or type 2 error occur, which is more serious. It says let P represent, so we're talking about proportions here as a percent, so that's why we're using P instead of mu. It says let P represent the proportion of the chicken that is contaminated. Inspector's claim is more than 20% contaminated. So USDA limit for salmonella contamination for chicken is 20%. So when I read that, okay, when we read that, that is the accepted true value right now, correct? Does that make sense? So from what we talked about yesterday, is that the null hypothesis or is that the alternative? That's the null. The null is always the accepted current value for whatever parameter, okay? So here we're using P. So now, this is just, like I said, reading comprehension. This is a little bit different than we said yesterday. Yesterday, we would just say, P equals 0.2, okay? But you got to understand that when we're talking about contamination, if I just say 0.2, it's very unlikely that if they hit 0.2, then that means that it's not contaminated, but anything to the right of 0.2 or anything to the left of 0.2 would be contaminated. Does that make sense? But when we're talking about contamination levels, say its limit for salmonella contamination is 0.2. So that means 0.1, 0.15, 0.19. Those are okay limits, right? Okay, those are okay values. So when we're going to write our null hypothesis here, we're going to write P is less than or equal to 0.2. Okay. Notice in this case that the null hypothesis still includes equality. Okay. Your alternative hypothesis is the complement. Okay, or the complete opposite perspective. Okay, if we were to graph these on a number line, these would be complement values. Okay, so this one is the claim, and why is this claim? It says an inspector reports that chicken processed or produced by a company exceeds that limit of 0.2. So the reporter he has this belief, he has this, maybe he's done some data collection, and that is what he believes to be true. So that's a claim. Does that make sense? Okay. Not always will the null hypothesis or the alternative hypothesis be the claim. We have to be able to read the scenario and identify that. Now, a lot of times what they do is they will use the word claim. Okay. This one says reports. Okay. Sometimes you'll see the word believes. A lot of them I have over here cut to the side that we'll go over here in a little bit. Use the word claim, but that's the null and alternative hypothesis. Okay, as a picture, this would be the idea. Okay, so if they're above 0.2, okay, our data, hopefully our sample data, will say that we are maybe above far enough. Okay, that says that our sample is representative of the population, and then there is maybe reason to reject the null hypothesis. And when I reject the null hypothesis, I reject that. And that means there would be evidence to assume that. Does that make sense? Okay. Or if I fail to reject the null hypothesis, then that would be that there is evidence to support that. Okay, which would mean that the company is not contaminating their chicken. This is what we talked about yesterday. I had this written out yesterday. I really want to talk about these first two. I don't know why it keeps moving around for me. Talk about these first two. It says, does original claim include equality? If so, the null hypothesis has to be identified as a claim. We talked about yesterday that the null hypothesis is the one that includes equality, right? Okay. So if the statement refers to somebody doing a report, somebody making the claim, somebody believing some piece of information, then that is the claim. Okay, the null hypothesis, because the null hypothesis has to have equality in it. If the claim says something to the fact that the report believes that there is less than or that there is greater than some value, so there's inequality, then that means the alternative hypothesis, because that's the one that has to have the inequality symbol in it, then that means that that hypothesis is the claim. Okay, and I think the best thing to do and realize that and practice that is just to see example after example after example, read it, write the hypotheses, and then identify the claim. I think that's very, very important for us before we move on to actually doing the test. These things here, I'm not going to read them to you, but basically it says, if I'm a researcher and I want, maybe I want to reject an established value of something, of some parameter, okay, then I need to word my study so that it makes my null hypothesis the claim. Does that make sense? Okay, because the null hypothesis is the only thing that we reject. If I'm the researcher and I want something that's going to support my claim, I want data, I want a test to be done that's going to support my claim, then I need to write the alternative hypothesis as my claim. Okay, because when I reject the null hypothesis, and that's evidence that supports my alternative. Okay, I know that gets real wordy, but this is going to make a lot more sense when we see specific questions. We run through the data, we get the values, and then we can write conclusions once we have specific scenarios. Okay, but I want to give you kind of an overarching understanding of what a hypothesis test is to begin with. All right, so we already talked about these type 2, type 1 error type things. Like I said, I'm not too concerned right now. Like when we see this problem here, okay, I'm not really concerned at the moment. And you don't write any of this down. You're just going to do some practice here. I'm not too concerned with you being able to say, okay, now what would type 1 error look like? How do we verbalize what type 1 error is here? Okay, or how do I verbalize what type 2 error is? We'll get to that. But right now, I'm more interested in, can we get the hypotheses written down? Can we get the claim established? And now get the ball rolling with doing actual calculations and then doing the actual test. And then once we have that done, maybe we'll come back and talk about the levels of type 1 and type 2 error. Okay. However, when you see problems like this and they tell you to test at a particular alpha, okay, that is relating to type 1 error. Okay. Type 1 error is usually more serious when we're doing these types of things, so we want to try to minimize type 1 error. But here it says a researcher claims, okay, so we see the word claims, right? So now as I'm reading, I'm going to try to figure out, do they use equality phrases or do they use inequality phrases? Because that's going to tell me, that's going to establish where my claim goes on my hypotheses. So it says a researcher claims that the average cost of men's athletic shoes is less than $80. Okay, so a couple things going on here. Average cost. Okay, what parameter are we talking about there when we talk about average cost? Is that a proportion? Is it variance? Is it standard deviation? Is it mean? That's mean, right? So we know we're going to deal with mu. So that allows us, because my fear is when we get to Chapter 9 test and we've got a handful of these questions on there and they're bouncing back and forth between means and proportions and variances and stuff like that, that we forget which test to choose. So we got to be able to know we're talking about the mean right now. So I'm going to say H sub 0 and H sub A. They're both going to deal with the mean. Okay. Now it says is less than 80. So less than 80, is that equality or is that inequality? Inequality, right? Less than is not, if it just said is 80, that would be equality, right? So is less than is inequality. So inequality always goes to what hypotheses? It's the alternative, right? Okay. So the alternative hypothesis here says that mu is less than 80. That was the claim. Does that make sense to everybody? Okay. The null hypothesis then is the complement of this idea. So less than 80, so this should be greater than or equal to 80, correct? Okay. All this other stuff that is in here, okay, so the 36 pairs, and then I believe it tells you the standard population standard deviation, all that's going to do is tell us to use either the z-test or the t-test, okay? And then we'll hopefully in the next 2 or 3 days get to the point where we can do that, okay? Go down to this next one. So the researchers' reports, so they don't use the word claims here, but they use the word reports, right? Okay, so if I'm a researcher and I report something, I'm basically making that claim, right? Okay, I'm establishing that that's what I believe. It says the researcher reports that the average salary of assistant professors is more than $42,000. Okay, so average, again, is mu, correct? So we're always going to have these two hypotheses. Talking about averages. Now, does this refer to the null hypothesis or the alternative? Alternative. More than has to be inequality, so it goes down here. And that's and this is the reading comprehension thing. That's attached to this statement here. That was part of the report. So that's the claim. And then this one here would be less than or equal to 42,000. So it's got to be the opposite idea, right? Or the complement. We'll jump down to, because that one was similar to the first one. Let's see if there's one that's different here. Let's do this one here. So the researcher claims that the average wind speed in a certain city is 8 miles per hour. Okay, so is refers to what? Equality. It means equal. Okay, so the claim right now is attached to equality, right? So when I say h sub 0 and h sub a, okay, talking about the mean again, or average, so mu. Now equality is the one that's got to be part of the null hypothesis, right? That has to have equality in it. So that one then is the claim. Is that okay with everybody? So then what would be the opposite of that? Not equal. Okay. And here's the idea. This is the reason we're doing this, and I'll show you this again, obviously, in section 9.3. Maybe it's 9.4. I got it in. There we go. So 9.3 is broken up into multiple sections. But here's the idea. If the claim is the null hypothesis, and you reject the null hypothesis, that's going to be, okay, so there is enough evidence to reject the claim. Does that make sense? Okay. Then this is what we would do. This is kind of the start of our conclusion or our summary that we would make in that last step of hypothesis testing. Okay, so let's say the claim is the null hypothesis, because that's what was going on right here. The claim is the null hypothesis. Let's say that we reject that. Okay, so in our wording, we would say that we can reject the claim, and then that would produce evidence, or that the data has produced evidence that would be supportive of this, that the mean average wind speed is not 8 miles per hour. Does that kind of make sense? So being able to identify the claim is ultimately going to allow you to better verbalize your results. Okay. Something that happens when we start dealing with this type of stuff, this hypothesis testing, is that when we choose, you see up here where it told me to choose, and each one of them tells me to choose an alpha level. Okay. 10% might be 5%. Sometimes it might be 1%. A lot of times you see 10 and 5. Those are the most common because they attach to basically confidence levels of 90% and confidence levels of 95%. If they tell me alpha to be 10%, I might, let's say, I might fail to reject at 90%. Okay? But I could do the exact same math And at 95%, I may reject. Does that make sense? Okay, so depending on the level of confidence that we want to use, or the significance level alpha that we want to use, at 5% you might not reject. At 10% you might reject, or vice versa. Okay, so what a lot of statisticians do is that they will provide you the statistic of the data from the sample, and they will say, okay, we're going to leave it up to you. Okay, what level of confidence do you want to use? Okay, what level of significance do you want to use? When I say level of confidence, that's like the 95 or 90, 99, right? When I say level of significance is the complement of that. So they're really tied together. But a lot of research papers will say, here is, we call it a p-value, which I'll show you how to come up with later. And then they'll say, okay, you then decide what level of significance you want to use, because at 5% you might not reject, but at 1% you might reject. Does that kind of make sense? Okay. So that's kind of what we'll investigate in the next couple days, next couple weeks. Does everybody understand the idea of the null hypothesis being equality, the alternative hypothesis being its complement, and then the claim, okay, if the claim includes equality, then the claim has to match the null hypothesis. If the claim includes inequality, then it has to go with the null hypothesis. Is that all right? Every problem from here to the end of the year, we're going to write two hypotheses, and we're going to identify the claim. Okay, and then everything else will be a little bit different depending on the structure of the data. Is that all right? There's a homework assignment that asks you questions like this, scenarios like this, but it just says, okay, now click the bubble that has the correct hypotheses written out, and which one is the claim and that kind of thing. So it's just trying to identify those components. Yes? Do I want a cough drop? No, why?